And this. Great. Okay. Thank you everyone for coming to our MATLAB workshop. This is workshop number 11. So let's just get started. First thing we want to cover is our little agenda. We're going to start with some introduction, and then we're going to go into MATLAB setup, and then a little lecture, and then an applications portion. We might not get through all the applications as they're quite long, but they'll be step by step. So first of all, why do we use MATLAB? Biggest reason is that it's a programming language, mostly for numeric computing. I wouldn't use it as like a regular programming language as we'd see, but as engineers and scientists, it is useful for analyzing numerical things. So it's not an orthodox programming language like, C or Python. So the biggest thing that sets MATLAB apart is that its basic data type is an array. So like, if you go into like Python, you'll have to set up an array. But if you just put any variable into MATLAB, it will automatically see it as an array. So where's my thing? So right here, we see an array is when it's just a set, like a table of data, but a matrix specifically is a type of array that only has numeric inputs. So that's a matrix 1, it only has numbers. We consider that a matrix, but it is an array still. And then it's really useful for matrices, as MATLAB means matrix lab. So next thing is setup. So if you go into the Hyperloop general chat on the Discord server, you'll see a link to get there. How to download MATLAB, it's this link. Otherwise, you can just go to Google, type in CPP software for students, and then this first link right here. And then you'll get like a whole table of software to download, but you're gonna go down to MATLAB, click that link. It'll lead you to the licensing instructions. You do have to make an account. It does have to be with your CPP email. And then when you click on the installer, you go through the process, it's gonna ask you, do you wanna download these additional things like Simulink? You can, but it's just gonna make the download go longer. So for now, at least just take the basic MATLAB. So let's go through that process. How many of you guys already have it downloaded? Okay, how many of you guys downloading it right now? Okay, that's fine. It should not take too long, hopefully. As you guys are downloading it, I'm gonna go into a little bit of lecture, but it should not hinder you or set you behind. So what are toolboxes? It's just like I mentioned, Simulink. These are the additional things you can download, and it's MATLAB and it's built on top of MATLAB to add more functionality to it. Like Simulink, it's good for like a more of a block diagram environment, and it's good for simulating systems before you integrate it into hardware. So that's a little picture of what you use Simulink for. There's a few other ones like the control systems toolbox, and the DSP, which is for digital systems processing, and then one more for image processing. And there's like quite a few. The general chat of Hyperloop, the Discord, yes. So first of all, what are the two main file types in MATLAB are the live script and the plain script. The live script is you code on the left side and your outputs show up on the right side, like they show up live. It's quite nice. Sometimes I don't like to use it because if I have too many graphs, it gets a little bit messy, or I see too many variables. It's not my favorite. I prefer the plain script where you just code and then you have to hit run and you'll see an output in the command window. So today we'll probably be using a plain script, mostly because I want the outputs to be nice and clear and you don't see all of them at the same time. So here you can, so like this right now is a .m file, as we can see. So this is just a script file. If I wanted to, change this into a live script, I'd go here. And I believe there is a function that changes it. I'm actually unsure of where that, there's a file that does change it, but usually I just copy and paste it, live script. But when you save it, you can choose if you want as a .m file or a .mlx file, which is live. Okay. Data types. Oh, go back. So for data types, the basic data type is an array. And then when you input a number, you'll get it as a double. So double means double precision. It's like a standard used, but usually up to 16 decimal places, it'll store it, but it's only gonna show it to you as 4 standard. There's other things like integers, just a 5, string, you know, like a word, character, a letter, and then complex number is when you have like the imaginary numbers come in. And then matrix is if it's A, B, and C, but those A, B, and C's are only numbers. If it was like a string, then you consider it an array. So there is a difference between matrix and an array. Yes, Chris?
Well, when you're trying to use those different types, you have to like kind of create a variable of string.
No, you don't. That's the nice thing about MATLAB. So MATLAB will assume your variable as you type it in. So I'm going to just do it here. If I just said x is equal to 3, it knows it's an integer. It's going to assume it's an integer. But technically, since I mentioned that MATLAB sees everything as a matrix, it's going to assume this is a 1-by-1 matrix. And we have a little matrix crash course coming up for anyone who hasn't taken linear algebra yet. So you should be good. But you don't have to do like, you know, another language where we said int var, and then you say go. You don't have to do that.
But it is possible to do that, right?
Yes. But if you just want to do string, you can just type it in quotes. And then these quotes can be double quotes or single quotes. It doesn't matter. I prefer double quotes. And then
You check that you're on the right mic.
right mic. Actually, let me take this off. Yeah, blue snowball.
Okay.
Can you hear it?
Yeah, no, the questions were just a little crusty on the other side.
Ah, okay. Oh, those questions?
Yeah.
Oh, you can't, doesn't hear everything? Oh, okay.
It's okay.
I'll just repeat the question. So one of the questions was, do you have to declare what type of variable you're putting in? No. If I just said x was equal to 3, it's gonna assume that it's a variable. I mean, an integer. Yeah. But if I wanted a string, I just put x is equal to quotes, and it's gonna know it's a string. Those are the 2 main ones we'll be using today. So matrix crash course, but just before, how many of you have it all downloaded? Who's still downloading it right now? Oh, still downloading? Oh, okay. What percent are you at? Or is it? Are you still?
I'm not sure. I'm like really like diving in.
Oh, okay. So we can go into a little bit crash course. So we're going to talk about how MATLAB sees data. So as I just mentioned, it's going to see everything as a matrix or actually an array if it has other data types in it. But if it's just numbers, just integers, it's going to see it as a matrix. So x is equal to 3, and it's in these square brackets. X is a 1-by-1 matrix, meaning it's 1 row, 1 column, 1 value, right? If I said y is equal to 1, 2, 3, 4, it has 1 row. So rows are linear. They go horizontally. And there's 4 columns because there's 4 vertical numbers, right? 1 this way, but there's 4 this way. 1, 2, 3, 4. So it's considered a 1-by-4 matrix. Are we all following here, numbering wise? And then when you want to insert like bigger arrays or matrices, like a 3-by-3, you could put it in this way. So z is equal to, if I said open square bracket 1, 2, 3, and I hit enter, it's going to automatically go to the next row, 4, 5, 6, and then hit enter again, 7, 8, 9. I think this is a bit tedious, not my preferred way. So what I would do instead is just go 1. You have to put spaces in between so it knows you're going to the next value in the row, or just put semicolon when you want to switch to the next row. That's how you'd make a 3-by-3 matrix. So if you're on MATLAB, you can follow along, just go to a new script file or just watch. This would output a 3-by-3 matrix, and probably hit run here. Where is the run? I can't take run. So as you see in the output, it had a 3-by-3 matrix. Both of them are 3-by-3. They both output the same thing. It doesn't really matter how you put it in. And the semicolon is the the character that tells it to go to the next row. Okay, so let's talk about a little bit what is a matrix. It's basically a rectangular array. or you can say it's a table, it's just a rectangular organization of numbers, and it does have to be numbers, is defined by m by n, where m is the number of rows and n is the number of columns. So quick question for anyone, what is the size of this matrix? That's because there's 3 rows horizontally, 1, 2, 3, and then 3 columns vertically, 1, 2, 3, 4. I mean 1, 2, 3. Sorry. And then each element is denoted by a location, I, comma, j. So I denotes what row is it in, and that index starts at 1. So in some other languages, index start at 0. In MATLAB, it always starts at 1. So keep that in mind. And then j represents which column it's in. So this number 6 right here is in the first row, first column. Its index is 1, comma 1. So what's the index of this 2? What was that?
2, 3.
Yes, so that index would be 2, comma 3. And then there's a few other ways we can define matrices, like further describe them, like up here. This is what I consider a diagonal matrix. A diagonal matrix is where this is the main diagonal. It starts from 1, comma 1, 2, comma 2, and then 3, comma 3, and so on. So where the row number and the column number are equal, that is the main diagonal. And above the main diagonal and below the main diagonal, it has to be all 0. And that would be considered a diagonal matrix. But more specifically, usually it's used in the context of square matrices. So right here, it's a diagonal square matrix. And right here, we see identity matrix. Identity matrix, it can be any number. It's n by n. It's always square. So, there's 1 by 1, 2 by 2, 3 by 3. And the main diagonal has to be all ones, and everything else is 0. And that's useful for when you're trying to find the inverse of a matrix. And by finding the inverse of a matrix, you can solve for linear systems. So we'll get into that. Next up, we're going to add and subtract matrices. We're going to do some MATLAB actually. So when you add and subtract matrices, you do it element by element, basically where the I and j locations are the same between. So if I want to add these two matrices, 1 and 2, I'm going to say 10 minus 6 is 4. 0 plus 3 is 3. -4 plus 1 is -3. And then 5 minus 7 is 2. So it's every corresponding element. Does that make sense? Like the locations are the same. And the same thing if you were to subtract. So if I wanted to put this into MATLAB and see, okay, let's subtract these two matrices. If you have MATLAB open, you can follow along with me. I'm actually going to clear these off. I'm going to put a parenthesis sign that's singular, means comment. So I'm going to say subtracting two matrices. I'm going to say matrix 1 is how I put my variable. It's going to be equal to open square bracket. It's going to give you the second square bracket already. And I'm going to input this matrix 10, 0, semicolon to go to the next row, -4, 5. And then I'm going to put a semicolon at the end of this line. This prevents it from showing it up in the command window when I run it. So if I were to hit run right now, it's going to show me matrix 1 in the command window. I don't really want to see this because this is just like an input that I'm putting in. This is not what I want to output. So I'll put a semicolon here. I'll hit run again. It doesn't show up in the command window. I'll knock this down. So the other one I want to put in is matrix 2, which is -6, 3, semicolon 1, -7. I'm going to put another semicolon at the end. So when you're like defining a matrix, you have to put these spaces. Otherwise, it doesn't know that it's a next value. It's going to think it's the same value. Other option is put a comma in between everything you want in the same row if you don't want to put spaces. But it's like the same number of characters. I suggest you just put spaces. It's easier to see. And then what I want to do is matrix 1 plus matrix 2. And I'm going to call this answer 1. Next thing I want is answer 2. It's going to equal matrix 1 minus matrix 2. So we're going to compare these two. I'm going to hit run. Oops. Why is it not going? No, I just forgot to put a space. Put a space there. There we go. In here? No. I just like it because it looks more spread out to me. So you can do it this one, it's fine.
Oh, wait, yeah, no, I thought like, what was the error?
Oh, the error was I actually put a space in between the variable name
Oh,
and it didn't recognize what the variable was.
Why don't you put a semicolon after that?
These two? Because I want it to be displayed down here. Otherwise, if I put it here, I put semicolons both here and I hit run, I don't actually see what the answer is. So semicolon hides it in the command window. It won't show it to you. So if it was like a constant, let's say you're putting in temperatures, right? You'd put semicolon after that. But if you want the actual equation you're solving for, you want that displayed. So you don't want a semicolon there.
Whatever doesn't have.
Everything is being run. If it has a semicolon, it just won't be displayed in the command window. That's all it does.
So it's like means that if you don't put a semicolon in it, it basically means that you're putting print.
It's a print. It's basically, yeah, print statement. Otherwise, if you put a semicolon, it's basically saying, don't print this. Like it's just to put into the program and only for the program to know. So I did run both of these. Let me run this again. First of all, this command was getting a little bit crowded, so I'm going to show you how to clear it. If I put CLC after the two command window lines and hit enter, it's going to clear my whole command window. If I put clear and I hit enter, it's going to clear the workspace. So the workspace is where all your variables are written down and their current values. It's very useful. So I'm going to hit run. And now we see answer 1, answer 2, matrix 1, and matrix 2. Their current values are listed right here. So answer 1 shows matrix 1 plus matrix 2. We can confirm this is true. They're the same. Answer 2 shows what it would be if we subtracted them. And we see that I did it element by element. So 10 minus -6 would be 16, and so on. Oh, another really big thing, the matrices must be of the same size. So this is a 2 by 2, right? Matrix 1. And the matrix 2 is also a 2 by 2. So by matrix rules, it has to be the exact same size. You can't subtract a 3 by 3. You can't do a 3 by 3 plus a 2 by 2. It won't work. But in MATLAB, it kind of follows these rules, but not really. So if I said matrix 1, let's say answer 3 actually, is equal to matrix 1 plus, I'm going to say a vector. So a vector is just a plain row or a plain column, like just one row or one column. I said 1, 1. So we're going to add 1. So what do you expect to happen? Error. Why? So by matrix rules, this should give us an error. But actually, what MATLAB does, run, it adds the vector here to each row of the original matrix. So if you were to do this in a linear algebra class, this would not be allowed. It'd be against the rules of math. But in MATLAB, since it's more about working with arrays and working with numbers, you can do something like this. So the rules of matrix operation are a little bit different in MATLAB. That's a big thing to point out here. Next up, matrix multiplication, which gets a bit complicated. So if you have a scalar or just a number times the matrix, it's just the scalar times each element. So it's element by element, simple. But if you have a matrix times matrix, it becomes the dot product of each row and column. So just here, who knows what a dot product is? Okay, so we kind of know what a dot product is. Best way to show this to you, I guess I'll just write it down. A dot product is when you're multiplying and adding consecutive elements. So if we look here, we see 1, 2, 3, and we see 7, 8, 7, 9, 11. So in here, we can say that, actually, I'm going to write this down. Let's do the dot product of 1, 2, 3. And 1, 2, 3. And I'm going to make this actually a comment. So if I want to do a dot product, we see that this is entry 1 of the first vector, right? This entry 2, this entry 3, right? And this is the second vector, same thing. So what you do is you take 1 times 1, and you add it to 2 times 2, and you add it to 3 times 3. That's equal to your dot product. So this is a more numeric explanation. Who can kind of see what's happening here? And this is if you don't know what the dot product is. So do you want to try? Yeah, okay. Well, what we're doing is we're taking the first element of the first matrix, or the vector here, and we're multiplying it by the first element of the second one, right? 1 times 1. So these are both the first elements of each vector. So we're going to add it to the second element times the second element.
Yes.
And then we're taking the third elements, multiplying them and adding them. And that's the dot product. So this is important because when we do matrix multiplication, the first row and first column, it's dot product. So this would be 7, 1 times 7 plus 2 times 9, which is 18. 7 plus 18 is 25. And then 3 times 11 is 33. 25 plus 33 is 58. So row 1, column 1, that's 1 comma 1, your output, and 1 comma 1 is going to be the dot product of those two, row and column. So does that make sense?
Yeah.
Yes. So imagine this was like a 10 by 10 matrix times a 10 by 10 matrix. That'd be a lot of, dot products. Be very difficult to calculate by hand. An interesting thing with matrix multiplication is the number of columns in the first matrix. So here it's 1, 2, 3, has to be equal to the number of rows in matrix 2. So 1, 2, 3. And then that is such that this is just a rule of matrix multiplication. Because if this was like a 2 by 2, and this was a 3 by 2, we won't have enough rows and columns to do the dot product. So that's just a rule. If you have an incompatible size, it won't work. Another thing is the answer is going to be the number of rows of the first one and the number of columns in the second one. So a 2 by 3 times a 3 by 2 gets you a 2 by 2. Does that make sense? Okay. And then my question is, what would a 3 by 5 times a 6 by 4 be, size-wise? Yeah, it's undefined.
Oh, it's not.
Yeah. So when you're doing matrix multiplication, so if this was a 3 by 5 and it was a 5 by 4, what would it be? So the inside values have to be the same for it to work. And if they are the same, you can look at the outside values to figure out the size. Okay. So that's a bit on matrix multiplication. Keep going. Okay, what is the transpose? This is actually a really useful function in MATLAB because typing out a very long vector and then trying to keep hitting semicolon or space is a bit annoying. So you can just use the transpose. What the transpose does is it keeps the main diagonal the same. But what it does is every row, so let's say this is 1, 3, 5, row 1 turns into column 1. That's what the T means. AT means transpose of T. So it's just going to flip the rows and the columns. So this first row, 1, 3, 5 became the first column, 1, 3, 5.
First column.
Oh yeah, sorry, first column, which is 1, 3, 5 becomes the first row, 1, 3, 5 in the transpose. So A transpose is this. What if I took the transpose of the transpose? It's just flipping it back to the original, right? So you just get A. And that's just a property of matrices. And then right here we have a little GIF of transpose. So that's A. It's flipping it over the main diagonal. Comes that. Then you can flip it again. So in MATLAB, there's 2 ways to do transpose that we're going to show. If I had a vector, let's say I had a variable x, and I did not want, and I wanted a vertical vector, right? But I didn't want to type it all out with the spaces. I just go 1, 2, 3, 4, 5, 6. I can either put this apostrophe at the end, and then if I put double parentheses, this is going to be a new section. So when I run the code, I can hit run section and only run this section. Oh, I didn't like this. I didn't like this. When calling a function or indexing a variable. Not like this, it's odd.
I think this possibly has to give less than very.
Oh, hold up. Yes, I usually use this function. So the other way to do it is transpose. Use parentheses. Put the vector you want to transpose and hit run section. Still doesn't like it. Oh, sorry. Doesn't like it. Okay, let's see. Might be missing a close in the index at 2. It's so weird. X is equal to 1, 2, 3, 4. And then I want where's this error? So odd. Fireworks line 14. There you go. Okay. And I wanted Y on section. Wow. Okay. It's really okay. It is working. I see what's happening. It's running the whole thing instead of running the section. So let me clear all of this. This will work now. Okay, so now we see that X was a horizontal vector. And I said Y is equal to X apostrophe, which makes it transpose. So Y is going to become vertical. The question was, can we make columns in MATLAB? Yeah, you can. You just go X, I'm going to say X1 is equal to, you can say it's 1, 2. And if you want to go to next, I guess you want to say, if you wanted 3 columns and like 3 rows, I go 1, 2, 3, I go semicolon, or I can just hit space and I go 4, 5, 6. So that makes it 3 column vector. And if I hit run section, oh wow. We see that this X1 is a 3 column vector. You can add to it. So if I said X1 and I want to add, let's see, Y prime has 4 rows. If I said this, I made it a 3 and I want to make this 3 by 3, I can say maybe Z is equal to, I believe there is a function. I've never used it before, but you can add them together. So I would say it's Y plus X1. Let's try running this. Didn't like this. Y is equal to X prime. Oh, still too many rows. There is a way you can append, like you're adding if you can add to it, right?
Yeah,
There is a function for that. I don't know off the top of my head. There's like a million different functions in MATLAB. You can probably just search it up. I've never used that function. But if you just wanted to add X prime, so which is 1, 2, to every column of X1, you can just do that and it would add 1, 2 to each. So this row increased by 1 and this bottom row increased by 2. So the other way to do transpose was if I said, let's go X3 is equal to transpose, the actual function. Here you don't need the brackets. You could add them if you wanted to, but it's not necessary. So I just type in the matrix I want to transpose and I hit run. I did not like my X1. No, it did not. Do this way. Run. It does tell you it's unnecessary though. Okay. That's interesting. I think if you do it in MATLAB, it tells you these are unnecessary if you want to transpose it. Or maybe that's when it's 1. So yes, this is also another way to transpose. Next slide. Okay, some other basics of MATLAB. How you format numbers. MATLAB has it set to where it just shows you 4 decimal places by default, but you can say x is equal to format long, and that's going to give you about 15 decimal places. And if I said x is equal to 4 point something with that many decimal places, and I hit run, it will show, wow. Okay, really giving me a lot of it. I can see, hold on, CLC. It's because I'm using MATLAB online. There we go. It's going to show me all these numbers. But if I didn't have this format long, still showing me this. Hold up. Format long. But if I don't want to see all these numbers, I'll go format short. And I'm going to say y is equal to x. Still doesn't like that. So it's going to show y with only 4 decimal places, because that's what format short does right here. There's a few other ones. If you do format short E, that's going to give you scientific notation, but only 4 decimal places. Long would give you 15 decimal digits and then scientific notation. There's a few other ones, like if you work with money, you can use format bank because you know cents. And then the bigger thing to note is that MATLAB uses double precision. So it's going to store it with 16 decimal places. It's going to store it in its memory with that. But it's only going to display 4. So that's its default. But it still has all the other numbers. They didn't go away. Okay, linear spacing of arrays. So if you're trying to go like, I want to make a table with days 1 through 10, and you don't want to type out 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You know how like Excel, you can kind of drag it and then it shows up all the consecutive numbers? We can do a similar thing in MATLAB where we can say x is equal to the first number that you want to start with. So let's say 1, and you're going to use a colon, and it's going to go till 10. So like 1 to 10 days. I'm going to run this. And then it says right here, x is equal to 1, 2, 3, 4, 5, 7, 8, 9, 10. And the default spacing is 1, so it's going to count up by 1. So this is good for things like for loops, maybe, where you want, you know, an iterative variable for I is equal to 1 through 10. It's going to run 10 times. We're not going to get too much into for loops today, but that's one way to space your variables. But let's say you want to count by 2s. So what would you do? We're going to say y is equal to 1 colon 2 colon 10. So the 2 is the spacing between your minimum and your maximum. So I'm going to go CLC. I'm going to hit run. X is just the original 1 through 10, and then y is it spaced by 2. So it'd just be the odd numbers in this case. Okay, and then next up is, let's say you know your minimum and you know your maximum, but you don't know the spacing, but you know you want 5 terms. So there's a function called linspace, basically linear spacing, and you're going to put parentheses. The first number you input in the argument is what is your minimum. So it's going to say it's 1. The second number you input is the maximum. So 1 through 10. And then I want to have the third number 5 terms in that array. I'm going to delete these. I'm going to clear this. Hit run. And then it's going to say, okay, the answer for this is, 1, 3.25, 5.5, 7.75 to 10. So it said, okay, from 1 to 10, I'm going to find the equal spacing that it would take for 5 numbers. So this is useful if you don't know how many, what the spacing would be if you want to equal, but you know how many terms you want in your array. And also note that linear space makes it horizontal always. But if I wanted to say like, oh, x is equal to linspace, and then I can say, okay, y is equal to x transpose. That'll make it vertical. I'll go run section. Now we see x, it did give it in a horizontal array, and y just changed it to vertical. And then you can use both of these to make matrices. So let's say I want to make a matrix Z where our first row is 1 through 10. So there's going to be 10 columns. And I hit semicolon to go to the next row. The next row is going to have, a lin space from 1 to 100 with a spacing of 10. So I expect to see, 10, 20, 30, 40, 50, 60, 70, 80, 90, and 100. And then I hit run. Okay, we see that Z is exactly as expected. The first row is 1 through 10. The second row is 1 through 100. It's actually counting by, I think, 11s. It's adding to get to 100. So you can use it to make big matrices if needed. Okay, next up. Because from like 1 to 100, I believe it's gonna take the difference and it's gonna add 11 each time to get to 100 with 10 terms I wanted. So it's gonna automatically choose the spacing if you don't know what the spacing is. So that's why it's useful. But if you know you want to go from 1 to 10 with a spacing of 2, you'd use 1:2:10. So there's a difference in terms of the argument. Here it's the min, max, and then how many terms you want. Versus if you're using, it's going to be the minimum, the spacing, and then the maximum. There's a difference. Yeah, sure.
So lin space and the colon is just two different same thing. Or could you replace the lin space with a 1:10:100?
No, because here, if we see, so the question was, is lin space and like the colon to make the arrays the same thing? They're not. So if I use colons, right, and I wanted to go, if I wanted to make the exact same array, this is what I'd put. Let's say this is A. And that's the reason is I didn't know from like, what is the spacing to get from 1 to 100, right? I didn't know that. I thought it was 10, but it was actually 11. So for lin space, it's going to go from a minimum to a maximum with a set number of terms. But you don't know what the spacing is. It can be like 3.3, and it's a hard, spacing to figure out. But when you use colons, you know what the spacing is. So if I were to run both of these, let's run the section. What am I looking at here? So Z, we see the lin space did count by 11s. I could get the exact same vector if I use this, but of course I had to use lin space to figure out that spacing. So it's two different applications. Do you know the spacing or do you not know the spacing? Choose. Next up, arithmetic operators. So basically, PEMDAS is what's used in MATLAB. So it's going to do, your parentheses first, exponents, then going to bias towards multiplication, division, then addition, subtraction. The two big ones to notice here are left division. It's essentially the same as like regular division, but you're dividing the denominator by the numerator. So instead of going, 3 divided by 5, if you had 3 left division 5, it's the same thing as saying 5 divided by 3. It's useful sometimes, mostly when you're trying to avoid using the inverse function in MATLAB, because the inverse of a matrix is quite slow, and we'll get to that later, but just keep in mind there's a difference between the left division and the right division. Next up. These are just some math functions that are in MATLAB and what their, syntax is. One to note that's important is the exponential function. This is really useful. It's exp. So if you want to say e to the 6th power, you'd write that as exponential 6. Yeah? No, these are the defaults. So there's a lot more that goes into like hyperbolics. There's inverse ones. You can just search these all up because there's probably a lot of functions. I can't name them all off the top of my head, but these are mostly the ones you're going to use for the applications today. So in the lecture, everything that's mostly used in the applications is listed on here. So rational operators. So this is like true or false type operators. the biggest one to note is the difference between, double equal sign and regular equal sign. Double equal sign is, is the right side equal to the left side? It's asking a question. It's going to give you a Boolean output, so true or false. And here, true is 1, and then false is 0. Versus the regular equal sign is, when you're assigning a variable, x is equal to 3 or 4 here. Versus me saying x is equal to 4. That's me asking, is x equal to 4? That's going to give me a 0 or 1 as its output. So in MATLAB, if you have a combination of like adding and then asking if it's greater than or equal to, it would say like 3 plus 4 is greater than 5. If I inputted this in, it's going to do the 3 plus 4 first. So it's going to go through all the adding and math first before it goes into these rational operators. So let me share this again. I hit run. Is 3 plus 4 greater than 5? Yes, it is. So the answer is going to be 1. It's a logical, meaning it's Boolean. And it's very convenient for comparing matrices. So if I said x is equal to 1 through, 30, with a spacing of 4 maybe, or 5. So I'm going to use colon because I know what the spacing is. And I'm going to ask which values of x are greater than or equal to 6. And I'm going to set that equal to y. So what I did here is I said the variable x is a horizontal vector from 1 to 30 with a spacing of 5. That's why I use colons. And my y is which values of x are greater than or equal to 6. So let's run this. Our command window, we see it. X is, 1, 6, 11, 16, and 26. And then y says their corresponding is going to have the exact same dimensions of your original array. And we see here that 1 is not greater than or equal to 6, so it says false. But 6 is equal to 6, so it says true. And then all the other ones are greater than, so it has 1 there. So if I had like a 3 by 3 array or a 10 by 10 array, I can quickly find every value that's, greater than a certain threshold. So what I'm thinking is, if you had a data set of, the average temperatures in the city and you want to know, oh, when was the temperature greater than 90 degrees? Because let's say that's a hot day. You can easily find that. Another cool thing is, so now that we found every value that's greater than 6, I can set another array that displays only those values. So if I said z is equal to x of y, so I put y in the argument, which is what the inside the parentheses, and I run this, z is only going to give me the values of x that were greater than 6. That's useful again in the temperature example, if I only wanted which days were greater than a certain threshold. So that's useful. We're going to use that later, I think. Okay, solving systems equations. Okay, so what's a system of linear equations is basically a collection of equations where there's no exponent. So we can see they're all to the power of 1. We're going to have the same unknowns, but different coefficients. So we see the unknowns here are x, y, and z, but there's different coefficients in each equation. And then there's only 3 options for what you'll get. You're either going to get one solution, no solution, or infinite solutions. But we're going to focus on solving systems with one solution or recognizing that there's no solution. And like why is if you're solving like an equation or like a system, you don't want to solve something that has, you don't want to try to solve something that has no solution because you're going to keep, solving it forever and ever. You're not going to get anything. So recognizing if it has no solution is really important. Versus if you want to recognize if it has one solution versus infinite. If there's infinite solutions, that's not exactly useful because that means you can just choose anything, right? Versus if there's just one solution to an equation, like a problem. Does that make sense? Because infinite solutions isn't really useful. Next page. Ax equals b is a big matrix equation. So the big A represents a matrix times an unknown vector, which is equal to a vector. So the matrix is the coefficient which are the numbers in front of the unknowns. So for this one, I'm going to write the coefficient matrix. I'm going to say it's A. It's equal to, it's going to be the coefficients in front of each unknown. So these are the unknowns. 4, 2, 3. I'm going to go to the next line. I guess I'm actually use the enter form. 2, -3, 5, 6, -1, and 4. So these are all the coefficients of the x, y's, and z's. And our unknowns here, at least the vector, it would look like this. X is equal to transpose of x, y, and z. So these aren't defined variables. I'm not going to run that part. That's what it looked like. And then the b vector is all your constants. So if the constant was on this left side, it'd be like 3z minus 1, right? But we want to move it to the other side so we can see what the b vectors or the constant. So b would be equal to the transpose of 1, -14, -1. And it does have to be vertical since it's vertical right here. And then here we see another one. A is the coefficient. X are the unknowns. So it's going to be, 1x1 plus 3x2 plus x3 is equal to 5. That would be the original equation. And then when we're solving them in MATLAB, there's two ways you can solve for x. You can use inverse of A times B. That's what I'm going to do right now. Let's say answer 1 is equal to inverse of A times B. Hopefully this does work. On the section. Nope. I didn't like this. Undefined. There we go. Okay. And then it told me what my outputs are. Answer 1, it says right here. Okay, that means x is actually equal to 2, y is equal to 1, and z is equal to -3. So, when you learn algebra, you solve like substitution or like canceling out. This is a much faster way to do it. Because imagine you had like 11 equations. That'd be really hard to do by hand. So instead, if you just convert your coefficients into a matrix, convert all your constants into a vector, and then use inverse of A times B, you'll get all the unknowns. But as I mentioned before, the inverse function is quite slow. So it even says here, inverse of A can be slower and less accurate than A left division of B. So if I did left division A, left division of B, I'm going to get the exact same thing. And MATLAB says it's faster. And then we can even see that I went to 4 decimal places. So it's even more precise. So if you're solving linear systems, always, you don't have to, but try to use the left division. And we'll use that when we solve them. Okay, plotting. This is the fun stuff. So when you're plotting, there's just the plot command in MATLAB. If you just plot one variable, it's going to give you as many points as was in the yesterday.
Sorry, in the system, would it work the same with B normal division of A?
B normal division of A. I believe. Well, matrix multiplication goes on each side. So if I did matrix 1 times matrix 2, that gives you a different answer than matrix 2 times matrix 1, right? So division wise, I'm actually not sure. We can try it. Why not? It goes easy. I've never done it that way. So if you were saying if we did B left, like regular division of A. Okay, let's try this. No, because the matrix dimensions don't agree. So yeah, that's not how we do it. Because that would be saying like a 1/3 times a 3/3. But the insides don't agree. So when you
That would be the point. It's like 3 by 1.
But MATLAB doesn't accept it. It wants it in left division form. It's just a faster way to do it. Anywho, back onto this plotting. The plot command gives you a graph. So if I just said plot of one variable, and I said y is equal to, I don't know, 1, 5, 7, and 10. I said plot y. I hit run. So I did, oh no. Should not have used MATLAB online. Oh. There we go, it did work. So we plotted y, which is just the vector, and it's gonna give me 1, and then it chooses the x scale by default. But we can see that it's 1, and then 5 is another point, 7 is another point, and then 10 is another point. So it's only gonna give me points at where I said the original vector is. But if I said I wanted to plot like x, y versus x, I can say, x is equal to, I'm gonna use 1 to 100 with a spacing of 5. So this is why the colon method is really useful. You don't have to input the whole array. So if I said plot, let's hope this doesn't crash again. It might. No, sorry. You have to put x comma y in the argument. Nope. This must be the same length. I see. And then 1, 2, 7. I see. It says it must be the same length, but it has to be ordered pairs. I need 20. So 1 to 100 with 20 numbers in it. If I run this. No, didn't like it. Didn't like it. Right. Oh, I did plot it. Good. So it's just gonna show a linear line because they're equal to each other. Thing I want to talk about is line specifier. So default is just a blue line that doesn't really show much. So if you wanted to add something that makes it like red, you're gonna go string, and then there's a bunch of line specifiers that you don't really have to memorize. But if I wanted like a blue line, no, I already have a blue line, a green line, I'd put G right here. And it has to be in strings. So I'm gonna hit run. And I changed my line to green. You can use these like letters or just type in red if you want to do that. That's your red line. If you want to add points where certain things are. So I want to add points on this graph. It's called marker type. You can put that before. Let's say it's right here. I'm going to put a plus sign because I want to mark it with a plus. So every line or every point is now a plus sign. These are all just formatting options. Here are some examples. If I said plot X, Y with just R, they're just going to give me a red output. Right here, this gives a dashed line with yellow colored. This one would just give me points that are stars. And then that one, let me check. I believe that's a green. That's a green dotted line, and they're connected with diamond markers. You want to see that one? So it'd be G. Yeah. So they're diamonds, and then if I zoom in, you can kind of see the dotted line right there. That's what it is. It's green, and then dot is the colon, and then D, I believe, means diamond. That one's not. Yeah, D is diamond, as listed right here. And then colon is right here, line style. The specifier is a colon for dotted. But if I wanted a dash dot line, I'd simply go dash and then dot. I hit run. So green's not a very good color. Let's change it to red. I feel like that's easier to see. You guys all see that? There's diamonds, it's red, and it's dash / dot. These are all formatting options. The D is for diamond. So if I look here, Yes, the data points are. So that's what a marker type is. Marker type is each ordered pair. So if I wanted, let's say I guess a 5-point star, I've never used this one before. Let's run this. I see a 5-point star for every data point. If I want to just do red with a 5-point star, I believe this would work. These are just saying, oh, we just want red 5-point stars. So there's probably many combinations you can make. These are just tables you can search up, or you can just search up marker types, MATLAB, and it'll get you the documentation for them. Next up is how to add text on a plot. These are functions. How do I zoom this out? This one smaller. Oh, no, you can't see that. Let's see. Okay. So how to add text on a graph. So say you make this plot, but you want to, add axis titles, plot titles, and a legend. We do have commands for that. So if you just plot something first, I'm actually going to go back to this. First, you have to plot something, and then right after on the line, you're going to put title. And then in string, you're going to put what you want on top of it. So let's say random plot. Love that. And then if you want axis titles, you'd go either X label, Y label, and then you put it in strings. X number. And you can keep going on. The legend is interesting because the argument for the legend is what you want to label the first line, then the second line, then the third line, or how many ever lines you have. And then the grid function, grid's not on here, but you can go grid on if you want grids on your graph or not. Let's speed through this. If you want multiple plots on the same figure, there's 3 ways you can do it. You can either say first you plot something, and then you can either go hold on, which means you're holding that figure, and you're going to plot another thing. Other option is to plot something like this, and then use a line command for the next one. Let's say X, comma, Y. And then if you want a third one, X, you go, X, comma, Y. And then you'll have 3 lines on there. Like here, seen. The one I think I used for here is an extended argument. So it's going to be each set of X and Y. So X, Y, and the next one would be, I'm going to use the same X, but it can be Y1, and it's going to graph a different line. And then we'll see that more in applications. Just do intro. Then log plot commands are one of our applications does feature this. It's how you change the scale of the axes. So by default, each axis is on a linear scale. But if you want a log scale, so log base 10 for the y-axis, you go, instead of plot, you use semi-log y. And then you go your argument. If you want the log scale on the x, you'll use semi-log x. If you want a log scale on both, you'll use log-log. So the subplot function, let's go here. It's going to divide the figure into multiple plots because you don't want to put 12 graphs and then have 12 different figure windows open. You just want one with 12 graphs. So it's going to have m rows and n columns, which is the first specifier. M, I want, let's say, at least in this one, it has 2 rows. It has 6 columns, so I would have put in subplot 6, 2, and the P represents which index you're at. So this would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh, there's only 10. And we'll be using this in the future. Okay, finally on applications. So does everyone have MATLAB ready? Yeah, Chris?
Go over F plot and think what is F plot?
F plot? The function plot?
Yeah.
Oh, I didn't put that in the curriculum. Should I? Okay. I don't remember.
So F plot, which I think is pretty important, especially if you're in electrical engineering, is basically just plotting the function. So in case for this kind of like function, you need like actual points to specify when you're plotting it. For F plot, you need the function. So basically, if you're doing something like y equals mx plus b, you're gonna do like F plot y, and it'll just graph the entire function without using points. then if you want to use plot, you need linspace, which basically breaks up your variable into a bunch of little chunks, right? In fplot, you don't need to do that. So it saves you some time, and sometimes it's just a quicker way of seeing a function.
Mhm.
That's all.
Yeah.
You have to specify the arguments, but that makes the final step.
So it'll be specifying the function itself. Basically, you're saying the variable will be specified at the beginning of the code. Not sure what was it in that case
For which one?
for variables? Like x, it would be
Well, X would be some sort of range.
no, it would just be a variable, right?
Yes, but you want to plot it over a certain area.
Fplot doesn't care about that. It just cares about it being a third. Right? I need to find out what that is.
Yeah.
It's pretty important if you just want to get a quick graph of points. But usually for like this case, just like regular plot with linspace would give you more information overall. But I know especially when I began learning this stuff.
I've used fplot before, but usually I just solve for the equation and then just graph the equation right from there. That is one of our applications. We'll see that. So, Chris, can I continue? Hold on.
Yeah, you can do. I'll go back to this thing.
Okay. So the first application, is everyone in MATLAB open? Are we all downloaded? Okay, good. We're going to solve a truss. So a truss is basically a bunch of members connected and they're joined at the ends. So a positive force is going to be tension, a negative force is compression. But once you go through all like the statics of it, this is more mechanical engineering, civil thing, you're going to have a giant set of linear equations. Right here, I have 11 equations that we're going to solve. It's honestly not that bad, I swear. It's going to take us less than 5 minutes to do this. And yeah.
You can picture to describe this situation.
Oh, a truss? Okay, I'll show you. Truss. A truss, like a bunch of members combined. And what we're solving for is the force in each member. So the question is it tension? Are we pulling it apart? Is it compression? Are we pushing it in? So that's negative. But of course, like if you do this by hand, it takes forever. I'm doing this right in a second. It takes forever. And I wish I could use MATLAB on my homework. I really do, because it would take me less than 5 minutes to do the whole thing. So again, this is why MATLAB is useful. I have 11 equations written here. So my question is, what are the unknowns? It's like, what are the variables? Okay, and how many F's are there? There's 11. Okay, I have 11 unknowns, 11 equations. Is that solvable? Yes. If I had 12 unknowns and 11 equations, that's not solvable, right? Because it's a linear system. So when I went over A, x equals B, what did we do with all the coefficients? We turned into a matrix, right? So the coefficient of this F1 is cosine 50, right? So now I'm going to make an 11 by 11 matrix using every single coefficient. So I do have the answer here just to make sure I don't mess this up. Oh wow, this is big. So A is going to be my matrix of coefficients. So if you want to do this along with me, open brackets. And I'm not going to use semicolons in this one because I'd have a very, very long line of like 121 characters. I'm going to use spacing. So for F1, we have cosine 50. Oh, an important thing about cosines. If you put cosine of 50, it assumes radians. If you put cosine D 50, that's now 50 degrees. We're in degrees, so make sure every single trig function is using the D at the end. So cosine D, so cosine in degrees of 50 is F1 space. F2 has a coefficient of 1, okay? And then F3 to 11 have coefficients of 0. So 0, 2, 4, 5, F6, F7, F8, F9, F10. Yes, you have to specify it. Yes, you do. You could maybe, but I feel like it's probably better just to write it out. Because then you'll have, you know, what if you had actual values there? Okay. So if I hit enter, on the next one is sine 50. I'm gonna hit tab on this. Sine 50, there is no F2 or on. So just 2, 3, 4, 5, 6, 7, 8.
Oh, sine D.
Wait. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. That's 11. And then there's a 400 here. Yeah. Parentheses. Yeah. Okay. Good question. I don't know. I've always used it in parentheses because it asks for the argument in parentheses. So I'm assuming you do need parentheses. We can try it without.
Oh, wait, no,
It's-
I mean, like, I think like they're asking about semicolon, like, you're missing a semicolon.
No, because I'm using the enter method to go to the next row. It-
Oh.
If I use enter, I don't have to put a semicolon. Because if I use semicolons, it would be like 121 entries in a singular horizontal line, which is not fun. So I'm just using enter. I could put semicolon, it doesn't do anything. It doesn't harm you, it doesn't help you. So I'm just using enter. And then the next one, okay, my question was, in this equation, we have a 400. In this one, we have an 800 and 1200 and 1933. What did we do with constants in the ax equals b equation? What did they become? Remember? No? Okay, it's fine. It became, no, yes, I transposed the b vector, right? So the b vector is all the constants. So basically anything that doesn't have a variable next to it, it moves to the other side of the equation. So all the way at the end, yeah, because the A is only the coefficients of the unknown. So our unknowns are F1 through 11. So I'm only going to look at those terms and find its coefficients. All the other terms that are just constant that don't have an unknown next to it, we'll move it to the other side to become our B. So let me continue this one. This is negative. Oh, F1 is 0, F2 is -1, F3 is 0, 4 is 0, 5 is 0, 6 is 1, 7 is 0, 8 is 0, 9 is 0, 10 is 0, 11 is 0. Next line, 1, 2, 3, 5, 6, 7, 8, 9, 10, 11. Okay. Next line, run this one. So it's negative cosine D of 50. And then we have F2 is 0, 3 is 0, 4 is 1. Then we have cosine D of 41 for F5, 6, 7, 8, 9, 10, 11. It's a very long matrix. And then go next. Okay. Fifth one is negative sine D 50. And then we're at F2 is 0, 1, 0, sine D 41. So that's it for 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 1, 2, 3, 4. Negative cosine D. 1, 5, and then 6, 7, 8. 6, 7, 8. There goes that. This one. 5, 6, 7, 8. 9. So yeah, it's a very tedious matrix. I'm now on this equation. So sine D 41. 6, 7 has 1, 8, 9, 10, 11. And then 1, 2, 3, -1, 5, 6, 7, 8. 9, 10, 1, 2, 3, 4, 5, 6, 1, 2, 7, 8. 11. And 1, 2, 3. a whole matrix in here. It's an 11 by 11 with all of its coefficients inserted. So are we still typing? Yeah, it's okay. So one thing I always do, if it's a really long matrix, go through every single row and make sure you have 11 entries in there. So I'm gonna go 1, 2, 3, 4. Yeah,
I
Chris?
think another way to do it is like generate an 11 rows and then populate each of the
Mhm.
coefficients.
Yeah, you could. Pretty sure you could. I don't think I've ever done it that way.
Huh?
I don't think I've ever done it that way.
Yeah, I'm trying it right now. It seems cool.
Mm. Are you just editing it in the workspace? Yeah. Okay. If you want to try that, you can do that. That's just A, and I'm not going to display this because I do want to display this. Run. This statement is incomplete. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. What's incomplete?
Why is it cosine B inside?
Because it's in degrees. So if you just put cosine 50, it's assume 50 radians. But I want 50 degrees. It says this is wrong. Oh, it is wrong. It's missing the closing bracket. And if I said run, okay, right of my answer. Okay, I do have an 11 by 11 matrix. So this is just all the coefficients. X is what is the unknown. So if I have the equation AX is equal to B, we don't know what X is, but we do know what B is. B is equal to all the all the constants. So in the first equation, I'm going to use transpose of a vector. The first equation has a constant of 0, 0. Oh, this one is actually 400. It's going to be 0, 400, 0, 0, 800, 0, 1200, 0, 0, 4,933, and 0. So I have 11 elements horizontally, and I do need it to be vertical for the left division to work. So that's why I'm using a transpose. So tell me, is everyone still typing? Yeah, okay, still typing. So let me try to show it to you. No transparent. Are we done typing? Yeah? Okay. So now we're going to solve for X. So our question was, oh, what is the force in every member? That's going to be our vector. Well, actually, I'm not going to call it X. I'm going to call it vector force, or at least the variable. Force is equal to A, the coefficient matrix, left division B. And if I were to do this, DLC, run section, we found that right here shows us the force in every vector. Ooh, right here in 11 terms. But I want to put this in a quite of a nicer form. I want to say like, oh, member 1 has this force, member 2 has this force. So I'm going to hide that. I'm going to use a variable I'm going to call member number. So it's like, the number of the member. I'm going to set that equal to the transpose of 1 through 11 with just default spacing of 1 because it's 1, 2, it's counting. I'm not going to display that. And then I'm going to use a function called answers 1, and that's going to be equal to a table. So a table is a function that makes a table of certain variables. So the first variable that I want on the left is member number. I'm going to put comma. So the variable I want next to it is force. So I'm going to put a force right here. And the output, I'm going to hide that too. I'm going to use the function called display. So display just makes it so you don't see answer 1 is equal to, but we're going to display answer 1. I'm going to put clear this. Are we all caught up? I see some typing. Okay. So what did we see here? So we had our A as our coefficient matrix that we typed in. B was the constant matrix we typed in. We solved for force using AX equals B. So A left division of B, AKA, I'm gonna put actually a comment here. This is the same as inverse of A times B. So linear algebra, you do it this way, inverse of A times B. Member number was just, list of the numbers of members. And then I put it into a table, the number right here, with the force. So now it says, okay, in member 1, we had this force. Member 2, we had this force. And this is just a nice way to display your data. That was the final output we wanted. And it is the same. So is everyone to this point where they have this table? No? Okay, what's up?
Something from my first line.
With your what?
First line.
Or you're just missing something in your matrix. They can't solve it. Transpose. So I think I had this problem when I was doing the first time. I was missing like a 0 somewhere. So go through each row and just count how many elements you have. Anyone else having problems? No? Do you guys get the table? Yes. Okay. Yeah. Table function is very useful. So if I wanted to add like a third table, if I just wanted to add like maybe another, I can just go 1 through like 13. And 1 through 11 actually, because it has to have 11 rows. So I run section. Oh wait. It doesn't say it like it actually. Nope. I'd have to put another variable here. If I said var 3 is equal to 1 through 11, I can put var 3 also in here. Yep, that's what I was missing. And then I can add another column if I wanted to. So you can have like 10 columns if you wanted to, if you had 10 different variables you wanted to show. But that is it for this application. Raphael, did you get it to work? Still counting?
Yeah, just now there's something like event, so I bring for NP.
Did you transpose B?
Yeah.
Hmm.
So yeah, 0, 0, 0, 0, 0.
Yeah. Interesting. Do you have 11 rows in A? Did you hit every?
Probably so 8 runs now. So it's
And then if you go to your workspace, what does it say A is?
A is 10 times 11 double.
Yeah, you're missing a line. So look a little bit closer. That's a good way to use a workspace. If you're looking for, do dimensions agree? This is 11 by 11. And his wasn't, said it was 10 by 11. So that's why I wasn't agreeing. So I think you're just missing a line. You're missing a line? Okay, there we go. Okay. So I'm gonna move on to the next one because we don't have that much time. Or Okay, the next one is the ideal gas law. What I'm gonna do is I'm gonna start a new section. That's what the double parentheses do. So if I say run section, it's not gonna run the top of this. This is called the ideal gas law. Okay, so ideal gas law, if you took chemistry, you probably should learn about it. It relates pressure, absolute temperature, so the Kelvin scale, mass and volume. We're using PV equals MRT, and this is different from PV equals nRT, where N is the number of moles. So we're using mass, not moles. So we have three constants, R, which is the ideal gas constant, T, 20 degrees Celsius. We do have to convert that into Kelvin, and M. We have three masses, 1 kilogram, 3 kilograms, 7 kilograms. And our goal here is we want to plot the pressure, P, versus volume, so V, for three of the different masses. And I want also a label, plot titles, and a legend. So this is a exercise focused on plotting. So how are we going to do this? We want this as our output. And I also have 3 colors. When I did this, I didn't actually specify the colors. So MATLAB does automatically change colors for every new line. Wait, actually go back. We're gonna go here. Okay, so the first thing we want to do is insert in our constants. So we're gonna have R is equal to 286.7. And I'm gonna put a semicolon because I don't want to see that. T, I'm gonna put TC to specify its temperature in Celsius is equal to 20 degrees. I'm gonna put TK, now I'm specifying this as temperature in Kelvin. So how do we get from Celsius to Kelvin? So this, I'm actually putting TC plus 273. And then last one I want is M, but there's 3 of them, so I'm gonna call it M1 is equal to 1, M2 is equal to 3, M3 is equal to 7. And then semicolons. So I do have my equation, PV equals MRT, and I'm solving for 3 different pressures. So I'm going to say, okay, the first pressure is P1. That's going to be equal to M1 times R times TK, because we're multiplying T in Kelvin. And then I'm going to have to divide this whole thing. So I'm putting in parentheses by V, which I don't think I specified in here. Oh, yes, V is everything. Okay, V was actually specified here. V goes from 20 to 100 meters cubed. And then I'm going to go in steps of 0.01 because I want a lot of points to get a smooth curve. If I just said 20 to 100, it only have about 80 points. So it look a bit jagged. If I say 0.01 as a spacing, it'll be a nice smooth curve. So where did I put P1? P1 is equal to this. So this is probably going to give me an error if I run it. It does. And it says line 41 equals unrecognized function TK. I see why. There you go. And it says matrix dimensions must agree. And that's because when we're doing these operators, it wants to use matrix math, right? But I don't really care about matrix math right now. I just want to divide each element. So if we want to do element by element operations, you just add a dot in front of the division. And I'm going to do it for each of these. I just do this in case it gives me an error. So now I shouldn't. Yes, it gave me everything I want. And I'm going to hide this. So the reason I put the dot was because V is a, what is this? 1 by almost 8,000 versus, I believe TK only has 293. So the matrix dimensions don't agree, but I don't really care since I'm only looking for elements. Does that make sense? Yes. So if you want to just do element by element, just add a dot in front of, any plus, any minus, any multiplication, division, any of that, those operators. And then P2, similar idea. You can just copy this, paste it. P3, same thing, except the only things that are changing in here are the masses. Everything else is staying the same. And now I'm going to plot all of these. I'm going to say plot. What's my x axis? Volume, so V. And then what's my y axis? Yeah, so I'm going to say, P1. And then do we remember how we're going to put like multiple lines on the same plot? Line, yeah, that could work. What's another one of the other options?
Add more arguments for
Yeah, so that's my favorite way to do it. So this is the first, this is the first X, this is the first Y. I'm gonna put comma. Next is the second X. It even tells you right here, X2. The X2 for us is the same because we wanted to plot against the same volume. So we're gonna put V again. But now our Y value is different, it's P2. And then we're gonna put another set, V, comma P3. So when I plot this, I should get 3 lines, not just one. Another option we could have done is we could have said, plot V, P1, and I could have said hold on, which means, don't go to a new figure. I could have said plot V, P2. That's another option. Do hold on again, plot V through P3. I don't like that because there's just a lot of extra lines of codes. I think the adding an extended argument is the easiest. So we have this, and then I want to title this plot. So I'm going to use title, and I'm going to call it in strings, pressure versus volume for 3 masses. The next line is going to be the X label. So I'm going to label the X axis in string again, volume, meters cubed, and put them parentheses. The Y label is going to be pressure in newtons per meters squared. And then the legend, because it's going to give us 3 different lines. So the first line is going to be P1 because I put it here. The second line is going to be P2, and the third line is going to be P3. So in our legend, we have to put in the same order. Parentheses. The first line is 1 kg. Then I need to put a comma outside the string to start a new string, 2 kg. Again, go outside the string, comma, string, 3 kg. Okay. Are we all here? I still see people typing. Oh, wait. Let me know when you got here. And then... Oh, yeah. There. 1, 3, and 7, 1, 3, and 7. Yeah, there we go. Are we all here? Yes, yes, okay. I'll actually make this bigger now. I'm gonna hit, why does it like this at all? Don't need to display this front section. So this is our output. It does look as we expected to right here. Did everyone get here? Did you have to get this image? Is there any errors? No? Okay, okay. So this exercise taught you, how to put multiple lines on the same plot, how to solve an equation for certain things, and then use the X. You're specifying the X axis to a certain variable, and taught you how to put a legend. Yes?
how did you get the Windows Office like separate?
Oh, that's because I'm on MATLAB Online right now. What you could do is just like open up a live script and it'd kind of display right on the side. I don't like live script because it kind of just keeps all the variables there, even if I go section by section. And I think just the .m file looks a bit cleaner for when I'm just coding something. If you were to turn it in, I'd say go for a live script because you can format it with headers, bolds, italicized. Good for reports. And then also sometimes the live script, if I have 10 graphs on like the same subplot, it doesn't let me make it look nice and big. That's why I like the .m files more. Okay. Yes, Sri?
So this graph is given from 40 to 100.
Mhm.
So, and just so that's equal.
Mm-hmm.
How do you, can you just plot for all units
From all-
infinity to positive?
Probably could. I think that's what the f plot function does. Because I'll go from all v. We can try this. It's the function. Okay, so the reason I'm not using fplot is because I didn't specify the variable, but that is possible with fplot. Because otherwise, if you don't put any specifications to the v, it's just gonna put it to just the numbers that are given here. They're just gonna probably do 1. So I'm gonna bring my v back. There we go. Okay, on to the next one. We might not finish this one because it's long. It's called diffusivity of carbon into iron. So iron is usually treated to make it stronger. And there's one process called carburizing, where you just expose iron to carbon so that carbon just kind of goes into it. It's pretty slow, but you can speed it up by heating it up. So we have an equation for it. We have some constants, what they represent. And then there's 2 types of, go back, metal. Alpha iron is body center cubic, and then gamma iron is face center cubic. This is just the orientation of the molecules. It just means they have different ways of how carbon ions can enter. And then it gives you a Q, which is the activation energy. So on the right side, we see what we want to put in our code. So we have some input constants. Oh, wow. Close them. Make this smaller so you can see the code better. But this is called diffusivity. So our first constant is R. R is equal to, I have it right here, 8.314, and you're gonna put a semicolon there. Temperature is gonna vary from 25 to 1200 degrees Celsius, so TC again, 25 to, okay, I'm actually gonna transpose this because I want it in vertical form, 25 to 1200, and I'm gonna count by ones. I'm gonna hide that too, and then TK is simply gonna be TC plus 273, and that's gonna be temperature in Kelvin. Next is, I'm gonna put a comment. These are the values for alpha. I'm gonna put, yeah, alpha iron. And alpha iron given here has a DO. Call it DOA to represent alpha of 0.0062 centimeter cube per second. I'm gonna hide that. Its Q of A, that means of alpha, is 8,000, 80,000. And then I'm gonna put a comment, and again, these are the values for beta, Fe. So DO, oh, it's not beta, it's gamma. DOG is equal to 0.23. And then QOG is equal to 148,000. We have these inputted. And then we're gonna solve for D of each of alpha and gamma iron. So DA, which is just the D of the alpha iron, is gonna equal to this equation. So it's gonna be the initial D, so DOA, because we're in alpha, times the exponent of parentheses, negative Q of A, because we're in A, divided by another parentheses, R times TK, and make sure it is TK. Double check that, yeah. And then because I know R and TK have different dimensions, I'm just gonna put points right before my operators. And that's all I need. So this is going to solve for the D, or the diffusivity of alpha iron. And I have that solved for. We're going to do the same thing. So I'm just going to copy and paste for gamma. And just change all these to G. But the R and T, K do stay the same. Okay, are we all up to here? Are we all caught up? Okay, we'll give it one more minute. So currently all I did was set up the constants and the equations that we're solving for. Did Shanta? Yeah, okay, are we all caught up? Okay, next up, I'm gonna put a comment. Then now we plot all of these. Okay, so I had two types of iron, alpha and gamma, but I want 4 different plots. One is on a linear scale for both. One is on a semi-log X scale, semi-log Y scale, and a log scale. So our output is going to look something like this. So we're going to pull up first we're going to start subplot. Subplot says, okay, on the same figure, we're going to divide the region into some row and column, like I said. So even here it says number of grid rows. We want 4 plots, so 2 rows, 2 columns, and we're first going to put in the first slot. That just tells the program, okay, you're going to put the graph here. And we're going to plot. The x-axis is temperature, but the inverse of temperature, so 1 dot divide of TK. And then pause. And then you're going to have DA. Yeah, Chris?
What's the third argument?
This one? Yeah. So if I go back to, okay, I guess you can just see it on here. So the first argument tells the program how many rows do we want. So there's 1, 2 rows, right? Second one tells you, okay, how many columns do we want? 1, 2 columns. The third argument tells, okay, where do I put this plot of these 4 options? So it counts left to right, top to bottom. So this is 1, this is 2, this is 3, this is 4. So every time I'm going to put a plot function, I'm going to change this number, but this is going to be the same number. So it's going to be 2, 2, 1. I'm going to have next plot 2, 2, 2, and it's going to plot it here. So as we go along, you'll see the plots changing. So plot, the first one is the inverse of temperature on the X scale, and then dA, which we solve for up here, diffusivity of the alpha iron on the Y scale. On the same graph, I want diffusivity of the gamma iron. So I do 1, this temperature again, and put DG on that scale. That's the first one. And then I also want to put titles on this. So the title for this one's going to be D of C in Fe. So diffusivity of carbon into iron, linear, because I'm just using the regular plot function. The X label, which tells you, okay, what do you title the X axis? It's going to be inverse temperature. The Y label, or what is the Y axis, is labeled diffusivity. D, and then I also want to turn the grid on. And then I want to put a legend because there's going to be 2 numbers or 2 lines that show up. First is the alpha and then it's the gamma. So the first one's going to be, I'm just going to call it alpha. I put a comma, gamma. So we're all up to here. Yes, okay. Now, because I believe in laziness, we're going to copy that, but we're going to change a few things on the second one. So the second one is going to go in this second slot so that this becomes a 2. This plot is going to change to semi-log x because I wanted in the second slot a semi-log x. So it's not a plot command, it's semi-log x. And that just changes the x-axis to a log scale, so base 10. And then the title, it's just going to change here. This linear changes to semi-log x. The x label and y label is the same, the grid is the same, and the legends are the same. And that's why I'm just copying and pasting everything. We're gonna do this again. Paste. Changes to 3 now because we're 1, 2 on the third one. So second row. This is now semi-log y. But change these 2 values, and otherwise it should be same. I'm gonna copy it one more time and put this on the 4th value. This is actually the log function. Oh, I forgot to change it up here. Yeah, semi-log y. So this would be, change this to log, meaning both axes are now on a log scale. Log, and then the rest of it is the same. Okay, so we're all up to here? Oh, no, okay, we'll wait. Did you get everything right? Just do a copy paste if that's easy. Sure, come over. This is actually semi-log x. Think we're all cut up? Are we all cut up? Yes? Yes, yes, yes. Okay, now I think you just hit run. See the stuff. Ooh, did work. Okay. So do we all see this figure? Yes. So big things in here, we had 4 plots on the same figure, so it wouldn't open 4 figure windows. This is good if you're trying to compare, 2 different data sets against each other. And then we do have the legend here. So by default, the first one, which is alpha, is going to be blue because that's MATLAB. And the second one goes to red. The third one goes to yellow. You can change the colors in the plot function. If you have this, that is the end. Is there any questions? Yes. Oh, yeah, there's a function command. You can just write function, I believe. And then you can set up a function. You can name it something like random. You can set up parameters for it if you wanted to too, like, I don't know, X and Y. And then in the function, you can say what you want to do with it. And then I believe it's an end at the, yeah. Yes, I believe so. You can do most programming in MATLAB, but it's more used as a numeric computational thing. Yeah, because otherwise you can just use Python or something. Yeah. Like it can do for loops and while loops, it can do all of that.
That was Sims, SYMS.
Sims?
Sims.
Sims for what?
You just want to create like a
Function?
like a regular function,
Mm-hmm.
like Sims X, three likable sentences be, and you do that plot line. So this would just be your general variable. It's SYMS. It's used in electrical engineering. So
Okay, that's cool. Any other questions? No, no, okay, if not.
Yeah.
Okay,
your outro.
oh, okay, thank you for coming. Yeah, hope to see you at the next workshop. It's career development, mostly focused on resumes, cover letters, and interviewing. We do have 2 guests coming in to speak, so I'll be exciting. Otherwise, good night. Thank you.